continue on in lesson 6.2, we're now going to introduce variables into it. We're going to apply the same rules though, same properties that we've learned all along. So we're only going to do the front side of these notes today, and then you can practice with some homework, okay? So, simplifying powers of variable expressions, use the needed exponent properties. We've learned a ton of them. We're not going to run through them. Okay, how could I rewrite, number one, we really have a way that we could rewrite that would help us get that simplified.
X to the 1/5 power in parentheses?
Okay, is it just x underneath the radical sign?
No.
It's x to the 5th underneath the radical sign. So wouldn't we need to take x to the 5th? Isn't that really considered our base? So what we're going to do is we're going to say we have x, oopsie, I need a pen here. We have x to the 5th, and we'll put that in parentheses because it's got that power, and we're going to take it to another power. We're going to take it to the 1/5 power. So our index, remember, becomes the denominator of our fraction. Well, again, we just did this over here. I got a bunch of blank stares from you when I said, what do we do? Well, we take a power to a power, multiply the exponents, right? So we're going to take 5 times 1/5, or we could switch that around and say we're going to take 1/5 times 5. Or we could say it to ourselves like this. What is 1/5 of 5? 1. So this becomes x to the 1st power, because 5 times 1/5 is 1. 1/5 times 5 is 1. 1/5 of my $5 bill would be $1. X to the 1st power. But then would they show it that way in answer bank? They would just show it as x, wouldn't they? So there's our answer. Okay. Now, it's Rose. The 5th that's after the radical sign, you mean this 5 that's under the radical? This 1/5? Okay, what about that? Where'd that come from?
Does that 5 before the radical sign, does that get turned into?
That's the part that's where the 1/5 came from that 5, that index. Yeah. Okay. Anybody else? Okay, why don't you go ahead and just do the first step of the next one. Write it without the radical sign. That's what we did in our first step here. We wrote it without the radical sign. See if you can do number 2 without the radical sign. That's all I want you to do. So in other words, you're going to take the base to a power. All you got to do. I don't want you to do any more. That's all. Okay, Josh, what do you have? I see you back there done, so I'm just picking on you.
I have a to the 8th power in parentheses.
A to the 8th power
In parentheses
in parentheses
with 1/2 power on the side. Times b to 7th power in parentheses. 2.5 power on the other side.
Okay. Anybody else have it that way? Some other people do? Okay. No? No. I'm asking, my question was, does anybody else have it that way? That was my question. Okay, Josh, you stand alone. Josh, it's okay. That's right, actually. But probably not, there's probably one more thing something we could have done first that would then we could have led to that. Cameron, what do you think that could come from?
See a to the 8th times b to the 2nd parenthesis times to the 1/2 power.
Yeah. That's really all I'm looking for in that first step, you guys. Take the base that's underneath that radical sign, take that base, just leave it like it is. Just leave it like it is. Put it in parentheses. And then the index here is an invisible what?
1, 2.
2. There's an invisible 2 there. So that's why we're taking it to the 1/2 power. Then Josh already applied the property that says if you have a product, a multiplication, because notice Cameron said I have a to the 8th times b to the 2nd. I didn't even write the times. It's there though, isn't it? We have a product to a power. When you have a product to a power, you give each of the factors that power. So that's what Josh did. He took the a to the 8th, gave it its own 1/2 power. B to the 2nd gave it its own 1/2 power. Okay, now we have a power to a power times another power to a power. What are we going to do with a to the 8th raised to the 1/2 power? What can that become? Mia, can you help me out? What can a to the 1 or a to the 8th raised to the 1/2 power? What can I change that to? What can I rename that as?
A to the 16th power?
Okay, so we have to take 8 times 1/2, not 8 times 2. What's half of 8, Mia? 4. It's a to the 4th. We multiply 8 times 1/2, or take half of 8, that's 4, times, Emerson, can you tell me what b to the 2nd raised to the 1/2 power can be renamed as? B to the 1st power, okay. And is that how we're going to see it in an answer bank? Are we done? No, we can clean this up a little bit. How would they show this in an answer bank, do you think this would be? Trey?
A4, B.
A4?
A to the 4th.
Yeah, Emerson just did that too. She says B1. B to the 1st, A to the 4th. Okay, A to the 4th. What'd you say next, Trey?
B.
B, yeah. Here's how we're going to see that answer in an answer bank. They're going to clean it up. You don't need the multiplication dot between them because they're variables. They can be next to each other without it. And we don't need that to the 1st power. It's understood to be there.
So the
Okay.
third one is the same?
They're what?
The third one is the same as the second one?
Third one would be the same. Act the same? Yeah, this one's going to be, so you guys are ready to do the third one on your own. Go. Get the answer for number 3. Shmarky just pointed out we should be able to do it the same way. See my wrist. Give each of them their own 1/3 power first, okay? We're not that amazing yet. We're getting really good. My red step.
But I got the answer though. I took the shortcut. Am I supposed to do it?
Yes. I like that you added that last question. Am I supposed to do that? Yes, you are. So, would you look up right now and see, do you have these 2 steps of work? We're not going to skip steps yet. We're not there yet, you guys, okay? I want you to, remember what I said, I think I said this yesterday. Every time we write something down, what does it help us do? Memorize it and get it in there deep enough that we're going to retain it. So writing it down is okay. And yes, hopefully you can get to the right answer without showing all of that, but it's not going to stick there as long because you know what's going to happen. Pretty soon I'm going to move into some new material and you're going to be like, these are going to be gone.
Do you want the green stuff in?
So the green step should be there. The red step should be there. And now I'll do the next one in blue. What would I write in the next step? Who wants to help me write the next step? Okay, Shamarky, what is it?
X 9 to 9 1.
Can I simplify x to the 9th raised to the 1/3 power?
You want the answer?
Well, I just wanted to simplify it, Riley.
X to the third.
X to the 3rd. So in other words, I'm taking 9 times 1/3, and then I'm going to have y to the what now, Shamarky?
1
Y to the 1st,
and Z to the 4th.
z to the 4th.
That's what I was
Okay.
asking.
Oh, do I want the answer? Well, I did want you to simplify. I guess I could say that. We could call that the answer. But we're going to clean this up now, aren't we? We don't need multiplication dots. We don't need what else?
The one on the
The
line.
1. So we'll clean this up and say our final answer is Brighton.
X to the third, Y, X to the,
How about Z?
oh, X,
Yeah.
oh,
And typically, what did I say also happens in algebra? Not only do they clean up like multiplication dots and like exponents of 1. What else is algebra like?
alphabetized.
Alphabetizing for some reason. They like to bring English into this. Because if it's letters, they can say, well, let's keep you as good English students also. Okay. Anybody have questions? Yes, you need to show me these steps of work. I can give you a whole lot more problems to do if you're ready to just go from the problem to the answer. I can give you 50 of these and then we'll really practice. Is that what we need?
No.
Okay, so let's start number 4. What are we going to do? Seth, I'm putting you on the hot spot now.
16 parentheses.
16 in parentheses to the 1/4. How about we put the whole base in there? What else should I put in there?
Oh,
The whole radicand. That's called, it ends up becoming a base. Let's put that whole thing in parentheses. Whatever's under the radical sign, we're going to put in parentheses. And then take it, did you say to the 1/4 power set?
Yeah.
Right? Okay. That's how we're going to start. JC, what would my next step look like?
16 in parentheses. And then 1/4
Okay.
on the outside. And then times m to the 8th in parentheses. Times 1/4.
To the, not times, but to the 1/4.
1/4.
Okay, that's what I thought you meant. Okay, and, okay. Who wants to do the next step for me? I'm looking for some new, I gotta check out the people's vocal cords out here today, see if they're working. Ian?
You have to multiply 8 to 1/4
Okay, 8 times 1/4, and that's gonna become
M2.
m to the 2nd power. Okay, 1/4 of 8 is 2. And then over here, this means take the 4th root of 16, correct? Is that what that means? Okay. Or in other words, what number times itself 4 times is 16? Brighton?
4.
4.
Two.
4 times 4 times 4 times 4 is 16?
2.
2, yeah. 2 to 2. What to the 4th power is 16 in your powers table? It better be 2. 2 times m squared. Clean that up. Get rid of that multiplication dot. There's our answer. Okay, now I have a quick question for you before I'm going to let you start on the homework. We've learned all these properties. We understand how to apply them now. But do we really understand what this answer just tells us? Okay, so let's go back to this right here. What are they really asking for right there? What are they asking for? Remember that question that we started with a long time ago? What is that asking us for? It's not asking what kind of pizza you want. What Emerson said a little louder for me?
What times itself? What times equals
16 m to the, yeah. What times itself 4 times gives us 16 m to the 8th. Let's check it out and see if what we just did, do we like our answer? So that is asking us what times itself 4 times will actually equal, oh, I don't know why I didn't give myself more room here, which will actually equal 16 m to the 8th. That's what that is, that radical sign with that index of 4, that's what it's asking for. So we're going to fill in the blank with our answer here, and we're going to say, well, we got 2m squared times 2m squared times 2m squared times 2m squared. Does it work? 2 times 2?
4,
4. Times 2?
8,
8. Times 2?
16.
16. Whew, feeling good about that. M squared times m squared. What do you do when you take powers that have the same base? What do you do with their exponents?
Add
Add them. So 2 plus 2 is
4,
4. Okay, so we got an m to the 4th now times m squared. What's that?
M to the 6th.
That's m to the 6th. So now we got an m to the 6th times 1 more m squared. What's that?
M to the 8th.
M to the 8th. Feeling pretty good about our answer, folks. Because that's our answer. Because what was it asking in the beginning? It was asking us
What times itself 4
What?
times gives you 16
times itself 4 times gives you what's underneath that radical sign, 16 m to the 8th. So that should hold true for all of these problems, shouldn't it?
So why can't you just do this?
This is asking for what? What's number 2 asking for?
What times itself 2 times is a to the 8th power b to the 2nd power?
Okay. Are you feeling pretty good about that? A to the 4th times a to the 4th b times itself would be a to the 8th, b to the 2nd. How about over here? What's this asking? Number 1. What's it asking?
What times itself 5 times will give you x to the 5th power?
What times itself 5 times will give you x to the 5th? Is x times x times x times x times x to the 5th?
Yes.
Yeah. So when we get our answers, we also should ask ourselves, you know, what was I really looking for in the first place? And does my answer make sense? Or am I just happy I have an answer? Did I actually get what I was supposed to? Okay, now we'll start on homework.